Hi everyone, I'm Udyogi and on behalf of our group, I would like to welcome you to our presentation for PUSL3122 Human Computer Interaction, Computer Graphic and Visualization. Our project is called the Furniture Room Designer, a web-based application that allows interior designers to create virtual room layouts and visualize furniture arrangements in both 2D and 3D before any actual purchase is made. The problem we wanted to solve is pretty straightforward. When customers walk into the furniture store, they struggle to imagine how a piece of furniture will actually look inside their own room. Static catalog images just don't give you the confidence, so we built this app for bridge that gap. The system was built using React for the front end, Node.js, Express.js for the backend, on MongoDB for the data storage. For the graphic side, we use Ridge.js, a library called React 3 Fiber to handle our 3D visualization. Now, my specific contribution was the requirement analysis and the 2D canvas systems. During the early stage of the project, I worked on gathering the functional and non-functional requirements, and I also created the paper-based prototype that helped us plan the interface before we wrote any code. On the technical side, I implemented the 2D canvas room layout using the HTML Canvas API. You can see here that when the designer enters the dimensions, the canvas draw the room boundary with a grid overlay. Furniture items appear as scale shaped on this canvas. The designer can drag them into the position. The grid system built inside the Grid.js utility file, which handle the coordinate calculations and scale into every size in the room size. This 2D view is starting point of the whole design process, and from here the designer can switch to the full 3D view, which the team members will explain shortly. I will now hand over to Imasha, who will walk through the HCI design process, the front end.
Thank you, Udyogi. I'm Imasha and I handle HCI design, front-end flow and authentication. From HCI perspective, we create two user personas. First, Sarah, an experienced interior designer, and Kazun, a beginner, to guide our design decision based on real user needs. We also conducted usability testing with two participants using paper prototype. Based on their feedback, we improved areas like button size, color picker usability, scroll clarity, and add toast notification for save confirmation. On the technical side, I set up routing using React Router DOM. The key feature is protected route component, which is redirect users to login page if they try to access restricted pages without authentication. I also developed the login page with client-side validation and implemented the furniture context to manage global state across the application efficiently. Now I will hand over to Ashwin to demonstrate the main designer interface and furniture interaction features. Thank you.
Thanks, Imasha. Hey guys, I'm Ashwin. And my work based on this project was focused mostly on the interface design and the furniture interaction system within the room designer. From a design perspective, I was responsible for creating the storyboards that mapped out the user journey from logging in and entering room dimensions, adding furniture, all the way through to saving the final design. And the storyboards were really useful during the development because they gave the whole team a shared understanding of what the experience should feel like at each and every step. And on the implementation side, the main file I worked on is the room designer, which is the central page of the application. You can see here the furniture catalog panel on the side. Designers can browse by category and click to add any item to the room. And what I'm particularly proud of this is the transformation controls I implemented, Once a furniture item is placed, the designer can rotate it by a set number of degrees to face any direction, scale it up or down to better fit the space, and delete it if they change their mind. These interactions were designed with HCI principles in mind. Every action gives immediate visual feedback on the canvas, and the controls are clearly labeled that even a first-time user can figure them out without any guidance whatsoever. The theme and the global styling across the application was also something I handled, making sure the interface feels consistent and professional throughout. Now I will hand this over to Divya, who will now take you through the 3D visualization and graphics implementation.
Thank you, Ashwin. I am Divya. I was responsible for the 3D visualization, which is core part of our application from a graphic perspective. The 3D scene was built using 3JS integrated with React through React 3 Fiber. This allowed us to create and manage 3D elements as React components, keeping everything in sync with the app state. The screen is wrapped inside a canvas which acts as the rendering surface. I figured as perspective camera with a 50-degree field of view and positioned in dynamically so the entire room is always visible. For lighting, I use 3 types. Ambient light for the overall brightness, hemisphere light for the natural color balance, directional light as the main source with shadows enabled for realism. The floor uses a textured plane and wall are generated dynamically. Furniture is rendered either as simple shapes or imported 3D models with colors that update based on user selection. These elements, lighting, shadows, and textures work together to create a realistic and interactive room experience. I'll now hand over to Kavidu to explain the undo-redo system.
Thanks Divya. I'm Kavidu and my contributions covered the undo-redo system and the wall functionality and the usability system processes. Let me start with the wall system in the 2D canvas view. Designers can click to place wall points and the system can connects them to form the room walls. These walls are then automatically extruded into the 3D view. So the room structure you see in 3D directly based on what the designer draws in 2D. Now, one thing we identified during our usability testing was that users really needed the ability to undo mistakes, especially when placing walls and moving furniture. This was actually flagged as a concern during our mock evaluation with proper prototypes, and we made sure to address in the final implementation. The undo and redo functionality is handled by a custom React hook I built called useHistory.js. It works by maintaining a history stack. Every time user makes a change, the previous state gets pushed onto the stack. When they click undo, we pop the last state and restore it. Redo works in the opposite direction. This works for both furniture action and the wall actions independently. On the testing side, I ran 2 usability testing sessions with the participation and recorded observation about where they struggled. The key findings were that scroll indicator in the furniture panel was unclear and interaction order wasn't obvious to first-time users. These findings directly led to the improvement you can see in the final version. The clearer toggle button, the improved scroll affordance, and the toast notifications Imasha mentioned earlier. I also wrote the README file for the GitHub repository covering the project overview, tech stack, installation steps, and how to run the application locally. Passing over Susmitha now for the backend implementation and the final demonstration.
Thank you, Kavindu. I'm Sasmina Karnangara and I was responsible for the backend, the Express server, MongoDB database, API routes, and the save and load functionality. The backend runs on Node.js and Express connected to MongoDB via Mongoose. I built 2 main route files, one of the furniture catalog and one for room designs. The furniture routes handle adding new items to the catalog with GLB model and image uploads using multi-middleware and retrieving the full catalog for the front end to display. The room routes handle saving and loading designs. When a designer saves, the full room state, dimensions, walls, and all furniture positions get stored as a MongoDB document. When they load, everything comes back exactly as they left it. Let me do a quick live demo to bring everything together. I'll log in, create a room, add some furniture, rotate and reposition a few places, then switch to the 3D view to see the full layout with lighting and shadows. Now I'll hit save, confirmation appears, I'll reload and load this saved room, and everything is restored perfectly. That wraps up our presentation. Thank you for watching. This project was a great experience combining HCI design principle with real computer graphic implementations. And again, thank you very much.